Okay, so today we're on to simplifying radicals, okay? So simplify radicals means you solve the square root part. Of whatever is possible. And so there's several ways to do this. One is that you can write out all the different ways to multiply to 50. So option 1, we can go ahead and write out, so 5 times 10, 2 times 25, and that's all I can think of right now, and I say okay. So we write out the factors, and then where is the perfect square? Okay, this works really well if you have your perfect squares memorized. So 25 is a perfect square, so that means I can write this as square root of 25 times the square root of 2. And then I know square root of 25 equals whole number 5, and so that just becomes 5 root 2. Okay, that's option 1. For some people that works really well. I find the majority of my students like option 2. I call this the tree method. So tree method, I just take the 50 and divide it down by the smallest number possible. So 50 divides by 2, which goes 2 and 25. If it's a big number you don't know, you can use your calculator. And then 25 goes to 5 times 5. Okay? Then doubles go outside. You can think of them, they're a pair, they're going outside on a date. Okay? Singles inside. Singles stay inside at home. So that gives us the same 5 root 2. And it's the same math, because anytime you have the doubles, it just tells you, hey, square root of 5 times 5 becomes whole number 5. But a lot of people like it visually this way. It also helps when you have a bigger number. So if we have 108, so 108, I may not know right off the top of my head, hey, what perfect squares are there? And so I'm going to go in the calculator and say it's an even number, so I know it divides by 2. So let's do 108 divided by 2. Okay, that's 54. So 2 and 54. If I have really big numbers, that's especially helpful. 54 is still an even number, so I'm going to divide by 2 again. That tells me 2 and 27. Okay, 27 is no longer an even number, so next I'm going to divide by 3. And this is a small enough number, I know it now, so 3 and 9, and then 9 goes to 3 and 3. Okay, so now I've done all my numbers down here. I've divided out into my prime numbers. And so again, I'm going to circle my doubles. So this time I have 2 2s, I have 2 3s, and 1 3 is left over by itself, okay? So again, doubles outside. And so I have a 2 outside, I have a 3 outside, because we have 2 pairs, and then I have root 3, 1 3 is left over. And then you always multiply. If you have more than one number outside or more than one number inside, you always multiply. So that gives you 6 square root 3, which is your answer. Alright, now we get to the adding and subtracting radicals. So you can only add and subtract like terms. So like terms means they have to have the same radical. Okay, same radical or no radical. And so first thing we do is simplify. Okay, so I'm going to take my 24 and divide it down to 2 and 12, 2 and 6, 2 and 3. So there's my doubles. Those are my singles. And so I take my double goes outside, my singles multiply back to 6 inside. 2 times 3 equals 6. And then, if there's already a number there, I have to multiply those. So that gives me negative 6 root 6. Okay. These ones I can already tell. Those are already like terms. But I don't know if they're going to match this one also. So I'm going to go ahead and simplify. 20 becomes 2 and 10, which is 2 and 5. So 2 is my doubles. That becomes 2 root 5. And I multiply the 2's, keep my minus sign. So minus 4 root 5. This I just did the math. I know 20 becomes 2 root 5. Minus 2 root 5. Okay, so these are not like terms. So my final answer will leave negative 6 root 6 here. And then when I add and subtract radicals, I just add and subtract the coefficients. So that becomes negative 4 minus 2 becomes negative 6 root 5. And so my answer will still have 2 terms in it because I have a root 6 and a root 5. Alright, this one. 2 of these are already a 2. That's as small as I can go. Let's see if this one's going to match. 2 and 4. 4 is that perfect square, 2 and 2. So this also becomes 2 root 2. Which I have to multiply by that 3, so it becomes 6 root 2. So now I have 3 like terms, negative 2 root 2, negative 3 root 2, negative 6 root 2. I just add up all those beginning numbers to give me negative 11 root 2. Okay. So in pre-AP geometry, there is a lot of simplifying radicals. So make sure you're practicing with these. Go to Khan Academy for extra practice if you need it after this lesson. It also has helpful videos. Alright, the next two is just a quick review of Pythagorean theorem. You've seen this before. And so Pythagorean theorem is simply a squared plus b squared equals c squared. And so c is always the side across from the right angle. Okay, so that's c. A and b. It does not matter which side you label a and b. We just know that that was c. And so we take root 26 squared plus 11 squared equals c squared. Okay, so these calculators are really nice. If you're using these, you can do the square root, so it's control x squared, so the square root's in the yellow there, so square root 26, and then hit that same x squared button and square it. Or you can come out of the parentheses first. Squared, so it just did square root of 26 squared for me, and then plus 11 squared, and it'll do that whole line for you. If you don't have one of these calculators, you can still square root of 26 squared. Any number, square and square root are complete opposites, so any square root squared will just become that number, and so it becomes, if we're doing it by hand, just 26 plus 121, which is 11 squared. And we go ahead and add those to 147. And so 147 equals c squared. And then the last opposite of squared is square root. So c equals the square root of 147. When you've done this before, you may have typed it into your calculator and gotten the decimal answer. In pre-AP geometry, and most of regular geometry, we don't take decimal answers. We're going to leave it in radical format. But we have to see, can we simplify it? Okay, so we're always going to do our answer in simplified radicals. Okay, so same thing as we were doing up above. And so I'm going to take 147, okay, not an even number. I don't know the factors of 147, but I'm going to check and see. Does it divide by 3? Yeah, it divides by 3 and gives me 49. And so 147 divided by 3, 49. Now 49 I know is a perfect square. If you didn't know that, you would just try out different things, see what it divides by till you find it. And so that means square root of 147 becomes 7 square root 3. Alright, this one, they gave me C, okay? So now I have x squared plus 11 squared equals 15 squared. And so that becomes x squared plus 121 equals 225. I subtract the 121 to get x squared equals 104. And then I take the square root of each. And again, if you're using these class calculators that TA Inspired, you could put straight in 15 squared minus 11 squared. So you could shortcut from this first step where you wrote it out and just say, hey, I know I have to subtract because it is C, and find that same 104. So it's just your choice of which way you like to work it out. So now I'm going to do my steps. So 104 divide by 2, because I always start by taking the smallest one. It gives me 2 and 52. Divide by 2 again to get 2 and 26. Divide by 2 again to get 2 and 13. And 13 is a prime, I can't go any smaller. So my doubles go outside, singles stay inside, I multiply them back together to 26. And so my answer is 2 square root 26. Okay, so then the last step for today is distance formula. Again, you're probably familiar with distance formula. It's very similar to Pythagorean theorem. It's just instead of a squared plus b squared, we subtract the points to find out the change in x and the change in y. And so my distance formula, if you want to write it on your sheet, is just subtract the x's, x2 minus x1, very similar to slope formula, squared, plus y2 minus y1 squared. Okay, so I label again x1, y1, x2, y2. And I plug it into the formula. So negative 1 minus negative 8 squared, x2 minus x1, plus 4 minus 0 squared. Alright, 2 negatives makes a positive, so I join these into a plus sign. And so that gives me 7 squared plus 4 squared. And I do my math. 49 plus 16 equals 65. So my answer is square root of 65. I have to check, can it simplify? So we always check to see if it can simplify. Alright, that is not an even number. It is a 5, so I'm going to start dividing by 5. So if you don't know it, type it in your calculator. 65 divided by 5 gives you 13, which is a prime number. So no, we can't simplify. Our answer is just square root of 65. And again, we don't take decimal answers, we leave it in the radical form. Alright, so those are the notes. Again, if you need extra help, go to Khan Academy for practice, and there's tutorial videos there.